ahead and start off with a practice problem. Okay, I'll take one from your assignment if you have it and didn't get it or something like that. Like if you weren't able to figure it out, I'll take one like that. This special limit is what we need it to be able to evaluate. And today we're going to talk about where it comes from too. Okay, so hopefully you won't have to just flat out memorize all of that, although you do need it. Hopefully you'll understand where it comes from. That's the goal. Okay. Any from page 799, 67 to 78 that you were not able to get? That's okay. That's okay. If you didn't, it's not due until Monday. I understand that. But I thought if you started it and got stuck, then we would continue with that. 75 and 76. Okay, so let's take a look at 75 since it's the first one. Okay, page 799. We're told f of x equals 1 over x plus 2. Okay, that's what we're told f of x is, and this is going to be really, really similar to 76. Okay, it'll work almost identical, it'll work pretty much the same. So the first thing we need to do is we need to find all the pieces that go in our special limit. We need to find f of x, we have it. We need to find f of x plus h. Okay, those are the two things that change from one problem to the next. So f of x is 1 over x plus 2. F of x plus h is going to be what? Should I call on somebody or you can volunteer? What would f of x plus h be? Good. 1 over x plus h plus 2. You replace the x in the old f of x with an x plus h. Okay? Now we need to put f of x and f of x plus h into my formula. We'll call it that for now. So the limit as h approaches 0 of big fraction bar, h on the bottom, subtraction sign at the top. The first thing is f of x plus h. So I put 1 over x plus h plus 2. Minus f of x is 1 over x plus 2. Okay. All right. Yeah. Now the question is, how do I simplify so that I can cancel out h? That's what you want to do here. You want to get to a place where you can cancel out the h in the bottom because that's what's preventing you from being able to plug 0 in for h. So how do we get to a place where we can do that? How can we simplify the top? Looking for some fantastic ideas here. We will here in a second, but we want a single fraction in the top first. Because we do have a compound fraction situation. We have a fraction within a fraction. That begs to be flipped and multiplied. Okay? However, we need a single fraction in the top first. So how can we combine those two fractions that are subtracted? Okay, now what are you trying to do when you're doing that? Get a common denominator. Now, I can't just multiply top and bottom. I could multiply top and bottom by h, but that won't give me a bottom of x plus h plus 2, and you're not allowed to just add the same number to the top and the bottom. That changes the fraction. That's like saying 1/2 is equal to 2/3. I added 1 to the top and bottom. That's not true. Okay, so we do need to get that plus h down there, but there's no way to do it, actually. You can't just put a plus h in the bottom. So we need to get a common denominator. What do we do if there's no common factors? Like, how do you get a common denominator between 7 and 6? Multiply them by each other. Okay, so you're going to multiply top and bottom of this fraction by that guy. X plus h plus 2. top and bottom. And you're going to multiply top and bottom of this guy by that denominator, which is x plus 2. By the way, you can always get a common denominator that way. Multiply them by the other one's denominator. That'll work all the time. It doesn't matter if it's the least common denominator or not. Okay, so you get at the limit as h approaches 0 of x plus 2 on the top of the first fraction minus the quantity of x plus h plus 2, and it's all over the common denominator now, x plus 2 times the quantity x plus h plus 2, and that is all over h. Don't forget your overall denominator of h. What I did was we got a common denominator, so I wrote the numerators together in one common numerator. That's what you would do after you've got a common denominator. Okay? We're still not to a place where I want to flip and multiply this yet. We're closer, but we're not there yet. What might we do first? Good. Distribute this negative and combine like terms. Okay, so that's going to give you the limit as h approaches 0 all over h. I'm going to even write it first this time, that way I don't forget it. Except a little more space. Okay, all over h. The top is going to become, if I distribute this negative, I get negative x, negative h, and minus 2. The negative x and this positive x right here will cancel out. Okay, so it's like that will go away. This plus 2 and that now minus 2 will go away. What will you be left with in the top of the numerator? Good. Just negative h. So it's negative h over that. And now we're to a place where we'll do what was suggested a little bit ago. And flip and multiply. The question I have is, what are you going to multiply by? Like, how do I rewrite this? I'll go over here. So the limit as h tends to 0 of what fraction times what fraction? What do I multiply by? What gets flipped? Top stays, what is the top? You flip, you multiply by the reciprocal of the bottom. My question is, what's the bottom? Just h. Very good. Just h. It's not this. This is in the denominator of the top. Okay, so you're going to take negative h over x plus 2 times x plus h plus 2 times, instead of h being divided, it's actually h over 1. Flip that. You're going to multiply by 1 over 8. What happens? What can we do? Cancel the h's. But don't drop the negative. Okay? So this is going to be the same as the limit as h approaches 0 of negative 1 over x plus 2 times x plus h plus 2. Now what do we need to do? Now you can plug in 0 for h. Very good. And we're going to drop the limit notation as we do that. So negative 1 over the quantity x plus 2 times x plus 0 plus 2, which is just x plus 2. You can simplify that a little bit. X plus 2 quantities. Alex, does that help? Ava, does that help? Again, 76 would be identical to this one with just 2 different numbers. But this is actually the answer to what is the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay. What questions do you have? Even if you weren't here,
What questions do you have? Let me tell you where this comes from. Okay? So here's what you're finding. Before I do that, how do you find the slope? Between 2 points, how do you find the slope? Okay, that's slope-intercept form of a line that uses the slope, but how do I find the slope? If I have 2 points, and let's call them, I don't know, let's go x, y, and let's go x1, y1, and x2, y2. We'll go back to what you're used to. How do I find the slope between those points? Good, okay. Which one goes where? Y's on top, very good. Rise over run, remember? You have, okay, so vertical change is on top. So y2 minus y1 over x2 minus x1. I'm going to erase number 75. If you object, say so now, because I'm going to give you some time to write down if you wouldn't take a picture or whatever. Okay. Any naysayers, if you want to call it that? Any requests to leave it up there for another minute or two? I guess it's on the video, so after I post the video, you can check it out there. All right, so how does this relate to what we're doing? Well, we actually have a change in y over change in x. All right. I'm going to draw a little graph here. Let's say that this is the x value I'm on. The point that goes with that can be called x, and what do we put in the second spot? Oh, even better. Okay, if you said y, that would be correct also, but we can call it f of x. And our notation here uses f instead of y's, so maybe I'll go ahead and do that. So this function is called f of x. That means that at x, I have a corresponding height of f of x. Okay, so this point would be x f of x. Now let's say another point. Okay, let's say I go h units over here. That distance is h. What's that x value? X plus h. Very good. Let's call this x plus h. The y value that goes with that, the ordered pair, would be x plus h, or the x value. What would the y value be that goes with that? Whatever f of x plus h is. Very good. So x plus h is your x value. F of x plus h is the y value, or height, that goes with that. If I want to find the slope between those 2 points, let's write an expression for the slope of the line that connects those. I know that they're connected with a curve, but let's pretend they're connected with a straight line for a second. I want to know how steep is the line that's connecting them. Okay, so I'm going to write, what's the slope here? M would equal, let's rewrite our y2 minus y1 over x2 minus x1 using this ordered pair set. Okay, so let's see, y2 minus y1 over x2 minus x1. Anybody want to try it? Okay, now does it matter which order you subtract in? As long as it's the same on the top and the bottom, as long as you say x1, y1 was paired together and you've got them lined up, it does not matter, right? So what you just told me is perfectly correct. It's going to differ by a negative though. So let me switch the order. Like this one is farther away, so let me start with that one. So f of x plus h minus f of x all over x plus h minus x. This is our change in y over change in x formula written specifically with that set of points. Okay, can we do anything with this formula before I go any further?
Yeah.
How can I simplify it? The bottom, does the top okay, so the bottom I can take out the x. Let's do that. So f of x plus h minus f of x all over, what do you get in the denominator? H. Is there anything that you can do with the top before we go any further?
No.
Good. Good. There's no way to get this h free or this x free and start canceling things. Can't do that. Okay? This is composition. You did very well. Again, this is a y value. This is a y value. It should make sense that they don't combine. Here's my question. We found the slope between the 2 points. What does the limit as h tends to 0 do? Let's talk about that. The limit as h tends to 0. If I put that in front of this, what does that do to my picture? Does it shift it? What do you mean? Okay, now wait. Where is h on your graph? Yeah. What does h represent on this picture? A linear distance. Okay, what is it? What distance is it? I know it is h, but what does it represent? What distance does h represent? You're dancing around it. I like the idea of h becomes 0. I want to springboard with that, but the problem is that h is not a location on my graph. What is h? The distance between your points. Now let's use what you said. Okay, so we want h to become 0. We want the distance between the points to become 0. In other words, we don't want 2 points spaced apart. We want 1 point. We don't want the slope between 2 points. We want the slope at 1 point. And that's what this is finding. I got goosebumps because I love this stuff. If it makes sense, it's just like, it makes sense. Okay, sorry, I like it. It's fun. So this is the slope between 2 points. Yeah, you're all making fun of me now. It's okay. This is the slope between 2 points. And the limit as h tends to 0 of f of x plus h minus f of x all over h is the slope at a point. That's the difference. This is algebra 1, and this is calculus. But this is the slope at a point. So the word at is going to appear in some problems and going to be pretty significant. If you want to find the slope over a course of time, then you would use algebra 1. If you want to find the instantaneous rate of change, that's requiring calculus. Okay, so the slope at 1 point. Because you want the distance between the 2 points to be nothing. Fun?
No.
Not fun?
I realized that.
Well, I'll tell you this part. You've done the hard part. You've done the legwork of how do I evaluate the limit. Now we just need for you to wrap your mind around what does that stand for. It stands for, you ready? This is the slope at a point. You know how to find the slope, the linear slope between 2 points. What you don't know is how to describe the steepness of a curve, and this allows you to do it. Okay, so you know what the steepness of a line is. You know that you take rise over run. To find the steepness of a curve, it's going to change over time. That's what makes it a curve instead of a line. Okay, but the steepness is going to be this exact formula, and that's called the derivative. I can't hold it in anymore. Okay, you're finding the derivative. And there are two main concepts in calculus, both related to limits, and the derivative is one of them. The entire first half of calculus is devoted to derivatives. The second half is devoted to integrals. Okay, so you're learning a huge concept right here. It's fun. It's fun. Believe me, it's fun. Okay, so I didn't give you much new stuff yet. This is just all that there is new for today, but now we need to use it. Okay? Huh? We could start the assignment. Maybe we should talk about that. Okay? Let me give you one example and then we'll work on the assignment together. Does that sound all right? I might renege on that and do another example after lunch, but for right now we'll do one example together. Okay, so let's find the slope of the graph of y equals x cubed, or f of x equals x cubed. That's better. I'll give you a nice point. Let's say I want to be at the point 2, 8. Okay. So let's use our derivative. Let's use our formula for the slope at a point. What I need to know is what is the slope at any point on this curve. Okay, so I'm going to start by taking this limit. I'm going to set it up just like we did yesterday or Tuesday. Okay, so you're going to start by finding f of x plus h, just like we've been doing. So what is f of x plus h going to be? X plus h quantity cubed. Very good. Can you simplify that? I asked that a lot on Tuesday, and let's ask that again. Can you simplify x plus h quantity cubed? Yeah, how do you simplify that? FOIL on steroids. That's exactly right. You're going to FOIL it twice. So you're going to go like this. You're going to go, I'm going to use some mumble space. I'm going to put it right here. Okay? Because I'm not going to put it underneath that. I don't want to take up that much linear space. So x plus h times x plus h times x plus h. Let's figure out what this is. You can only multiply two things together at a time. You can't do three at once. Okay, so you're going to take two of them together. It doesn't matter which two, they're all exactly the same. Let's take the second two. Okay, so you're going to FOIL. So you're going to go first, x squared. Outsides and insides are going to combine to be 2xh. And lasts are going to be h squared. You need to take that quantity times the other x plus h. How do I multiply two things together times three things? You don't. Multiply every single thing times every single other thing, kind of, yeah. You're going to take each of these, x and h, times each of these. Each one of these is going to get a term with x squared, 2xh, and h squared. Okay? So let me take this opportunity to just show you an easy way that I really like to multiply, and I didn't really learn it until I was teaching. Okay, so let me show it to you. You learn in elementary school how to multiply 3 digits times 2 digits. Like if I ask you to take 325 times 17, how would you write that? 3-digit over the 2-digit, right? You put the 3-digit on top. So let's take the x squared plus 2xh plus h squared, and you put the 2-digit underneath that, right? And we want to multiply these. Let's write it like you're used to writing it. Now I'm going to get some colors. Okay? Now, when you're multiplying the 17 on the bottom, like your 2-digit number, you start with the ones place, right? And you take that ones place times each of the 3 digits up top. So let's do that now. Let's take h times h squared, h times 2xh, and h times x squared. And let's write out what each of those are. Okay, and I'm going to keep using black. Normally I'd use purple, but you won't be able to see on the video if I use purple. It's not dark enough. So h times h squared is going to give me h cubed. H times 2xh, what is that? 2xh squared. Okay, and then take h times x squared, and you get x squared h. Now, normally you have to do something called indent on the second row, and then you start taking the tens place of the second digit times each of those. Okay? Indenting is kind of relative. You want to line up the things that are alike. So here you go. Now we let x take a turn. So you're going to take x times each of these. Okay, so we're going to take x times h squared, which is what? Xh squared. And I'm going to line it up with the other xh squared group right here. Okay, so you get another xh squared. And again, I would write it in green because it goes with the green lines, except that you won't be able to see it on the video. Okay, so xh squared is what you get when you take x times h squared. Then we need to take x times 2xh. We'll get 2x squared h, right? And I'll line that up with the other x squared h. And put a plus sign between. Then I need to take x times x squared, and I get x cubed. Okay? I need to add these together. Isn't that what you do after you take each digit times each other digit? You add the quantity. Okay, so let's do that. You have h cubed, no other h cubes. We get, what's this come out to be? 2xh squared plus another xh squared is 3xh squared. Very good. Okay, and then we need to take x squared h times 2 plus 2x squared h. We get 3x squared h. Very good. You add. And you still have x cubed. You just multiplied 3 things times 2 things. If you like multiplying vertically, you can multiply 2 polynomials vertically just fine. Okay? And if that's what, I like this better, actually. I think it's much easier than trying to draw the swoops like you do with FOIL. Okay, so here you go. This is what that FOILs out to be. So this thing right here is equal to, I'm going to put it right here, x cubed plus 3x squared h plus 3xh squared plus h cubed. All right. Now we need to evaluate our limit. Don't forget where you're going. Okay, we need to try to find what is the limit as h approaches 0. Set up your big fraction bar, h in the denominator and subtraction on top. All right. F of x plus h is going to be this expression right here. So x cubed plus 3x squared h plus 3xh squared plus h cubed minus f of x, which is what? In case you've forgotten. X cubed. Okay, now we need to try to get to a place where we can plug 0 in for h. What are we going to do? Take out an h, not until we
Combine like terms.
Exactly, simplify, combine like terms. What like terms can combine? The x to the third, very good. If that doesn't happen and things without an h in it don't cancel out, you probably did something wrong. Okay, you want things without an h to be gone so that you can take an h out of everything that's left. So this gives me the limit as h approaches 0 of 3x squared h plus 3xh squared plus h cubed all over h. Take one h out of everything. So if I take an h out of everything, I take that h away from each of the h's up top. That h is singular. What about these? They need to reduce. So you reduce the power by 1. Okay, so that becomes h to the first. You're still left with an h. This becomes h squared. Okay, be really careful when you're reducing. Again, I said this on Tuesday, but taking an h physically out of everything and writing it in front would probably be a safer thing to do. Okay, so the limit as h approaches 0 of 3x squared plus 3xh plus h squared is an equivalent or reduced function to the one that I have. Can I evaluate now? How? Plug 0 in for h. So this limit is equal to what? Are you okay with there being x's in your answer? Well, it depends on what you're calling your answer. If you're saying, I'm okay with there being x's in my answer to what's the limit as h tends to 0 of f of x plus h minus f of x all over h, you're fine. Okay, but is that what we were asked for in this problem? Not completely. Okay, this is equal to a formula, listen closely. What you just found is a formula for the slope at any point on this curve. This is a curve. It has a changing slope. The slope at any x value on x cubed is equal to 3 times that x value squared. Okay? Exactly. So if I want to find the slope, which we'll call m, so m at the point 2, 8 is going to be equal to 3 times my 2 squared. The 8, I wouldn't say it doesn't have anything to do with it, but the 8 doesn't directly play into your slope. Okay, the 2 is what's playing into your slope here. If your slope formula had an x and a y left in it, you would use the 2 for the x and the 8 for the y. Okay, what's your answer to this? I got a square before I multiply. Very good, 12. So your slope at 2, 8 is going to be 12. You all don't seem nearly as excited about that as you should be. Come on, you just found the slope of a curve at a point. That you couldn't do that before today. You couldn't do that without calculus. You can't, like, you're now smarter than everybody else in the building. Well, aside from the 6th period people that have known how to do it since last fall. Okay, now, just to give you a little bit of a, I don't know, just to give you a little bit of a relief, they have developed a shortcut. How many of you would like to do this for every single problem? Yeah, there is a shortcut. There are shortcuts, I should say. There are different ones for each problem. Okay, this one happens to fit a pretty common shortcut. There is a way to get from here to here in one step. Okay, since you don't know the shortcuts yet, your problem set is going to be a little more limited, and I'm giving you more time to work on them. Until you learn the shortcuts, I won't give you 15 of these, okay, or at least not without time to work. I want you to get the practice, and I need you to know this formula. I need you to understand it and memorize it. Know it, okay? It's the slope at a point, and I need you to know what it is and be able to use it. So knowing what it is probably the first thing. Being able to use it and apply it is the second thing. Okay, so today we're really focusing on both. So we'll stop there for now. I'll give you some time to work on your assignment. Okay.